Hey, welcome back. Today, we're diving into something that sounds a lot like science fiction. We're talking high-tech alchemy. We're going to explore how we can take these massive mountains of our most complicated trash and with some really intense heat, turn them into something incredibly valuable. So yeah, let's get right into it. So let me just start with this question for you. What if fire could actually unmake our trash? And I don't just mean burning it to a crisp. I mean using really precise, controlled heat to break it all down, not into useless ash, but back into its basic building blocks. Stuff that we can then use again as fuel or raw materials. I mean, how cool is that? That's the huge idea we're going to unpack today.
All right, so here's how we're going to break this all down. First, we'll tackle the e-waste puzzle, and it's a big one. Then we'll get into what thermal treatment actually is. After that, we'll check out the different methods, see what cool stuff we can get out of it, and finally, we'll talk about the challenges and the really smart innovations happening right now.
Okay, first things first, let's get into the problem we're trying to solve here. We're calling it the e-waste puzzle. And you know, it's a real head scratcher because all our old gadgets, they're this weird mix of being both a huge hazard and, believe it or not, a potential treasure chest.
So every single year, we're piling up this just gigantic, growing mountain of what's officially called waste electrical and electronic equipment, or WE for short. Yep, we're talking about your old phones, laptops, TVs, you name it. And the thing is, it's not like a simple plastic bottle. It's this super complex cocktail of different plastics, metals, and chemicals all mashed together. And that makes trying to recycle it the old-fashioned way, well, almost impossible. And if you look inside this e-waste, it's just a wild mix. You've got all sorts of plastics, things like ABS and HIPS, the hard plastic shells on most of our electronics. Then you have valuable metals just waiting to be recovered. But, and this is the real kicker, you've also got hazardous additives. The big one to know is brominated flame retardants, or BFRs. They're put in there to stop devices from catching fire, which is good, but when you try to burn them or recycle them improperly, they can release some really nasty toxins, and that's a huge problem. So that brings us to the big what if, right? If normal recycling just can't handle this complicated mess, what's plan B? Well, this is exactly where thermal treatment steps in. The best way to think about it is like reverse engineering our trash with heat. Okay, let's get one thing straight right away. Thermal treatment is not just about burning trash, not even close. It's actually a whole set of really sophisticated, super controlled, high temperature processes. And they have a very specific goal: to break down waste in just the right way so we can pull out either the energy that's locked inside or the valuable materials it's made from.
All right, so let's get into the how. What are the actual methods? You can think of these as the secret formulas for our high-tech alchemy. There are actually a few different ways to do this, but we're going to focus on the two main ones.
First up is incineration. Now, the two key words here are controlled combustion. That means it happens with oxygen present. And believe me, this is nothing like a backyard bonfire. It's a super precise, highly managed process designed to shrink the volume of waste down to almost nothing, and, in today's plants, to capture all that heat it produces and turn it into energy.
So, a modern waste-to-energy plant works something like this. First, the waste gets pre-treated, sorted, shredded, that kind of thing. Then it's combusted at incredibly high temperatures. All that intense heat is used to boil water, which creates a ton of steam. That steam then spins a turbine, and boom, you've got electricity. At the very end of the line, you're left with some ash and, importantly, any metals that can be recovered. Okay, on to method number 2, pyrolysis. And this one is a whole different ballgame. Pyrolysis is all about heating things up in an environment with no oxygen. That's the key. Without oxygen, stuff can't actually burn. So a great way to think about it is that pyrolysis cooks the waste. It doesn't burn it. And the process is totally different too. The waste gets loaded into a sealed reactor. No air can get in. Then it's heated up. And this is where the magic happens. The materials break down into 3 totally new, really valuable products. You get a gas, you get a liquid called bio-oil, and you get a solid, carbon-rich substance called biochar. So this table kind of sums it all up perfectly. Incineration, that's about burning with oxygen. The main goal is to shrink the trash and get heat. Pyrolysis, that's about decomposing without oxygen. And the goal is to convert the trash into brand new materials, gas, oil, and that biochar. See? Totally different philosophies. And they lead to totally different results.
Now, besides those two big ones, there are a couple of other cool strategies worth mentioning. First, there's something called briquetting. This is where you take shredded plastics, compress them into these super dense blocks of fuel. They're called solid recovered fuel, or SRF, and industries can then burn these instead of coal. Pretty smart, right? Then there's also heat recovery. This is just about being efficient, capturing all the waste heat from huge factories like cement plants and using that energy instead of just letting it float away.
Okay, so after all this high-tech cooking and burning, what do we actually get out of it? Let's talk about the good stuff. It's time to go from waste to watts. Let's see how we can literally cash in on our trash.
Just look at this number for a second. Get this. Incinerating just 1 ton of plastic waste, that's roughly the weight of a small car, can create about 1,400 kilowatt hours of electricity. What does that even mean? Well, to put it in perspective, that's enough juice to power the average American home for almost 2 months. That is a mind-blowing amount of energy just locked away in our garbage.
And it's not just about electricity, not by a long shot. The amount of recovered gold you can get from this stuff is amazing. We're talking about heat for entire city districts. We're talking about metals pulled right out of the leftover ash. We get those solid fuels for factories and from pyrolysis. Remember, you get bio-oil and syngas, which are fuels themselves, and even that biochar, which is fantastic for making farm soil healthier. It's just an incredible range of useful things from stuff we used to just throw in a hole.
But, okay, let's be real. This kind of powerful magic doesn't come without a cost. So we've got to talk about the flip side, the challenges and all the new innovations trying to solve them. You could call it the price of magic.
And this really shows you the core dilemma, doesn't it? On the one hand, the promise is huge. Tons of energy, and way, way less trash in our landfills. But on the other hand, you've got the problems. You can get harmful gases coming out, and you have to figure out what to do with the toxic stuff that's left over, like the ash. So here's the deal. When you heat up these complex plastics, especially the ones with those flame retardants we talked about, it can release this nasty soup of harmful gases. We're talking about things like NOx and SO2, the same stuff that causes acid rain and smog. And dealing with those emissions means you need really good and, really expensive filter systems to clean the air before it's released.
But this is where things get exciting, because innovation is tackling these problems head-on. The way forward is like a full-on attack from all sides. For one, scientists are getting way better at pre-sorting the waste to pull out the hazardous stuff before it even gets heated. They're using advanced computer algorithms, even AI, to make the whole process run smoother and safer. And a ton of research is going into building better scrubbers to catch emissions, and also into finding new ways to use the leftover ash, maybe even turn that problem into another product.
And all of this leaves us with a really big fundamental question, doesn't it? Is all this high-tech heat the ultimate key to a circular economy, one where we get value out of everything we throw away? Or is it just a really clever temporary fix while we work our way towards a true zero-waste world? You know, the final chapter on that hasn't been written yet, and it's going to be fascinating to watch this space. What do you think? That's all for now. Thanks for tuning in.